Namastey Coders, I hope you are fine. So now we are gonna solve the lead problem from LeetCode 75. So today we are gonna solve the second problem from Q. Actually, we have solved all the first problem from all the topics, and that second problem from previous topics, which is stack has my prefix sum, and also now we are gonna solve the second problem from Q. So this video is a part of LeetCode 75 series in which we are gonna solve all the problems from LeetCode 75. There is another series in which we are solving the LeetCode problem of the day regularly, so you can check out those videos as well. I have uploaded that video of today's problem of the day. So here is the solution we have submitted, so you can check out that video as well. I have shared the link in the playlist in the description box. Along with this, one more thing, I have also created a WhatsApp group in which we can connect through lot many coders from all the part of the world, right? So that will be very beneficial. We can discuss multiple things, like we can discuss doubts, questions, algorithms. We can create some good project. We can connect to different coders of the world. We can gain some knowledge of different trends in the programming, industrial trends, and also we can do some freelance work as well, right? So I suggest you all to like join that WhatsApp channel. It's free, of course. It's of no cost, and you will get connected with different coders, right? So that's all. So let's start with the problem. So problem is Dota2 Senate. This is the simulation kind of a problem. So let me explain the problem to you. The problem says that the world of Dota 2, there are two parties, right? Radiant and Dire. What? So let me go through this question first. Read all the things, and then you will get to know. The problem is asking a simple thing. We have given a string in which a string called Senate, and the Senate string is a string holding senators, and senators are from two parties. One is from Radiant, and others are from Dire, right? The senators from Radiant can do two things, right? Any senator can do two things. First, it can freeze the power of any senator which is right to him, and the freezed senator cannot vote, right? Either it can do one thing, it can declare a victory if all the senators present in the court which has the power of vote, right, are from the same party. So let's say we have a string RD, right? So we will start from the left side, and we will ask the senator to do one out of two things. So senator will choose, of course, because all the senators are not from a single party, so it can choose only second thing, that it can freeze the power of this one of the senator from its right, and of course it will not freeze the power of the senator of the same party. So it will freeze the power of the opposite party, right? Then we have the senator from again the Radiant party, then it will freeze the power of Dire party. Now the both senator present in the string have are of the same party, so we can say that the victory is declared of the same Radiant party. Now if that is the case, then there are two senators present of a Dire party. What they can do, they can freeze the power to the right. So right means a circular right? So this will freeze the power of the Radiant, and this will freeze the power of this Radiant, of course. So they both are of the Dire party, so we can the victory is declared of the Dire party. So this is the question. So how? So we have to find that which party will win, right? So we have given a string. Let me check. We have given a string, and we have to predict that which party will win, of course. So what can we do? So there is in a native approach, we'll iterate through the Senate, and let's say we are uh, okay, so we have a string called rd r r d d d, right? So we'll iterate through the string with each word, and whenever there is a so we are at the radiant party, right? We'll ask the radiant to do one thing. Of course, the party, so the string contains the different senators, so we cannot declare victory right now, so it will choose to freeze power of the opponent one, right? So we'll iterate through the right and check if there is a senator of a different party. So yes, we have found a senator from a different party, so we will make this -1, right? That means it has no power. Now we will iterate and we check it's a -1, so we will iterate again. We have again encounter a radiant, so it will make it -1. Again we encounter a radiant, so it will make it -1. Now we encounter a dire, so it will make this -1, right? Then we have encountered this, so it will make this -1. So we have two radiants now, and they both are of the same party, so we will declare the victory of radiant. So as you can see, the time complexity is n square, because at every point we have to iterate through the string, and at space complexity is 1. So this is a native approach, brute force approach, using which we can solve this problem, right? But can we optimize this? This is a problem of Q, right? So can we use Q? So yes, we can use Q. Actually, I've solved this problem. So what I've done, we can make two Qs, right? One for the radiant and one for the dire, right? And taking the same example, we have R, let's say D, R, D, D, D. We don't have to iterate through the this string again to check the next opponent. We can use Q, right? What we can do, we have iterated through the array with index, right? So we are at index 0 and we have encountered our radiant, right? So what we'll do, we will insert 0 here. We will insert the index. Now we have dire, so we will index 1. Index 2 is R, so 2 here. So this is 2, right? This is 2. 3 is dire, 4 is dire, and 5 is dire. Now we have iterated through this string, right? Now what we'll do, we'll do a fight between them, right? So both of these will fight, and whosoever have a smaller index means it has gone a first chance to choose, right? So radiant has a first chance to choose what it will do. It will freeze its power and go at the back, right? And back means now it will get the chance after this. So this is 5, so it will get the chance after 5, which is 6. Now they will fight because they are at the front, right? So these both will fight. This 2 will get first chance, so this will freeze its power and go at back. Back means after 6 it will get chance. Now they both will fight. What will happen? The 4 will overpower because it got first chance, right? So this will freeze it and got at back. Back means after 7, so it will get the 8th chance. So these both will. So this is how now 7 and 5, of course 7 get loosened because 5 get first chance. Now we have nothing left in the radiant, right? That means dire will win. So this is how we can use the data structure called Q for our purpose to solve this problem in a better way, in a optimized way, right? So this is the power of data structures, of course. So we have made two queues. Actually, I am solving the problems in a C++, just for like getting hold on the C++ again, right? I will soon start the solving the problem in Java also. So yeah. So this is the first queue. This is the second queue. If the character is R, I will push the index in radiant, and otherwise I will put the index in dire. Now I am checking while both none of them is empty, right? Means both of them contain some senators. I will choose. I will check that if whichsoever has the lower index in the front, right? So if R is the lower index in the front, I will push R in the back, right? So, or index plus plus means the latest index plus one. Otherwise, I will push in the back index plus one, right? So and I will pop both out, right? So this is how we are doing. This is all we are doing, and check. And after this loop, one will get vanished. We will check which is vanished. So if R is get vanished, means tire is winning. Otherwise, radiant is winning. So this is getting solved in a like most optimized way, of course. Let's analyze the time complexity. Okay. So yeah guys, that's all from my side in this problem. I hope you understand it this well. So that's all. Thank you for your time. Have a good day.